Good morning, everybody. I'm just running through your assignment. Were you able to go through this and answer questions? Did you find any difficulties? Actually, I gave you about 20 questions, but if you, for the assignment, you have to do only about 10 questions. But if you answer all these questions, the CAT will be covered. Um, did anybody tried answering any of these? Do you hear me?
Yes, sir.
Okay. Anybody tried to answer these questions? Suppose like first question. What are the KPIs? That is key performance indicators. Uh, you already know mostly that what are the important uh, performance measuring indicators in manufacturing analysis. Like if I say for example cycle time or the flow time, utilization, work in process, throughput, those are the like there are a lot of performance indicators, but you may select few and answer, but you have to know as many as possible. So in second question, it's about single station manufacturing. Actually, I wanted to record this presentation for the single station manufacturing as last. I mean, when I did that, some of students are not there, but I was not able to do it last night. Anyway, like it won't be that difficult questions in the CAT paper. So if you in the presentation is given there, what is it? Single station manufacturing cell, single station manufacturing, and just go through that. So you all know what is a single station. That is one person may attain one machine in manufacturing. Those are used in mostly job shop production process, because it's kind of in you can, I mean, in job shop you can go for one product or like batch production in low quantities. If you think of the flow arrangement or the flow plan, flow production flow plans, so this falls into let me tell you what are the flow flow plans that you manufacturing flow plans, you know, or you don't know anything about that. uh, there was a presentation, a few small slides I have given you about these flow plans like production process flow plan and the production fixed product lay. I mean, flow plans mean layout, product layout, fixed product layout, or the process layout and cellular layout. So from this kind of single station manufacturing is more suitable for kind of product layout or process layout for producing small batches or single part. Give me a second. So single station manufacturing is mostly popular because it's easy to implement. It's uh, just a machine with one person or one station. So cost cost is less than the other systems, other manufacturing like manufacturing cells or whatever. So that's why. But just know what a single station manufacturing cell, and yeah, just know manufacturing cells characteristic like uh, let me see. Once you're answering, just go through that. uh, and third question, describe the concept of cycle time in single station manufacturing and how the cycle time is usually, just a minute. Cycle time is usually the time which takes to manufacture or to produce a product or single piece. So just know the correct definition. Usually cycle time is calculated using like number of parts and the time it, all the like uh, you can say like this: cycle time is equal to total operating time of a machine by divided by number of parts. So you get uh, part for hour or part for minutes usually. So usually you can say number of parts per hour can produce. So that means one part, the time it takes to produce a one part. Okay. Uh, so the next question, uh, I think this was in your very first presentation. Just to know these two words, variability and uncertainty. So as it in English, it comes variable. So, the variation or fluctuations can which can happen in production lines. Uncertainty is like whatever the kind of which not expected situations, like breakdowns, kind of those uncertain things what happened. That means like you cannot predict without any prediction whatever happens in the manufacturing line. So just uh, understand these two words and write down. uh, you already know, I have given you this slides, process layout and product layout. So in process layout, it is machines are operated, machines are organized in the flow, uh, from starting raw material to finished product, like in a organized sequence from one machine to machine. So starting from raw material, maybe forming or forging, then maybe milling, drilling, polishing, quality checking, shipping, like that. It's organized uh, accordance to process. And in product layout, it is organized considering the product, like usually in assemblies, like which product, which part should if I say, for an example, assembly line, like which part should come first, which part should be second, or which part should be the third turning part. Or in a shop floor, for an example, uh, maybe in that particular product, maybe first have to drill a hole, then maybe next have to machine a thread, maybe third operation maybe the cutting a slot. So depending on operation sequence. So it is for a product like mass production, usually product layout. In process layout, it's it is good for batch production. So just go through about, understand about layouts as well. So you have to remember those three type of layouts all the time, all the manufacturing layouts or product layout. So those are like fixed layout, product layout, process layout, and the cellular layout. Those terms will be using throughout. Also, remember about the what are the differences of, I mean, I just told you the differences of two layouts, and remember, find out the differences of all the four layouts, or the floor plans, whatever manufacturing layouts, and advantages, like why, how do you choose, and what are the advantages of different layouts. Okay. So you just think of this, what can be the possible obstacles implementing new facility layouts. So for an example, if you select kind of process layout, it is like you have to establish manufacturing process correctly and move physically locate all the machines like that. So there are like and if you consider like benefits of selecting layout, basically to reduce the production time actually, or the lead time, or double work in process time, progress time. So just understand those. And you already know what is cellular manufacturing. It's uh, production machines, two or three machines are grouped together and produce the particular component. So there can be two three work cells in a or many work cells in a production line. So understand this as well. Wait a second. Here, okay. Okay, the presentation that I have given you about cellular manufacturing, you have group technology and production flow analysis as well. So in know what is group technology and how group technology related to cellular manufacturing. Actually, about if you take a product, usually that product will manufacturing process of that product in first, okay, I say like this. If there are many products in the facility or we are designing many products, we'll be using group technology to classify or group products using similarities of product, like design or the shape or the material, whatever. So like that we can group similar products into one group, and the manufacturing process of that group will be easier because it has to go same process. So for that kind of process we can establish a manufacturing cell. Likewise, for each type of group, we can establish manufacturing cells. So finally, similar operations will be doing in each cell, and later each cell will produce a part. So the parts will be assembled later on. So grouping can be done considering part manufacturing part similarities, or in other way, if you are if you consider about the layout, what I said, process layout, Grouping can be done considering manufacturing operations, like like in a, if you say if a part has turning operations, or similar, or if a part has, like, no, just think, similar machines can be grouped together. Lathe machines can be grouped together, or milling machines can be grouped together, drilling machines can be grouped together, forming machines are, or press machines are, can be grouped together. So uh, in different ways you can group. So just go through that. And what I want to say is, what I want to say is, so understand, when you group using group technology, and then you can, it relates directly to cellular manufacturing. So for cellular manufacturing, basic principle is grouping using group technology. Make group and make work cells. You have production flow analysis also. It's a part of uh, group technology. You about consider production process and how you group machines. So these are related to cellular manufacturing. When you are grouping production machines, considering the product flow, you have you are making PFA chart called production flow analysis chart. You don't have to learn about that, but just remember what is production flow analysis. So this is, we discussed already. uh, do you have any questions up to 10th question which you didn't understand? No questions? So you understand everything what I say? Okay, go through the presentation slides and the book as well, I mean the notes you have, and answer up to this. So 10th question. So if I tell you the most important, hold on. Can you still see the screen? Because I lost it.
Yes, sir.
Yes,
We
sir.
can see the assignment.
Okay. Let me see. I cannot see it at the moment. I'll stop and reshare. Okay. So I just want to tell you the important questions that you have to remember. It's not, I mean, you can mark on your assignment. Oh, I'll just tell like this. So, no, I will mark, let me see it. So, go through question number one, question number three, question number four, question number five, question number seven, question number eight, question number nine, question number 10. So those are important questions up to 10. So let's see from 11. Uh, it's about flow lines. I have given a presentation slide. I thought of modifying that again and do a recording on that, but I couldn't do it. But I will tell you up to, what you need up to now for if it comes, if you could talk about the CAT. Uh, yeah, I need to. I will check the. I don't remember the what is there in the slides. So just need know what is a flow line. Flow line is, you can say it can be a transfer line, or it can call just a second. It is usually a sequence of workstations or production machines operate to finish a product. These flow lines are called, sometimes you can call transfer line as well. It's it's the same meaning, like a part can flow throughout stations, workstations, like work cells. Also, a part can transfer from station to station, from machine to machine by flow line, by this type. So it's called flow line or transfer line. And there are two types, like continuous and intermittent. uh, it should just, I'm not sure whether it's I have highlighted in the presentation slide. So continuous translines it machine what I said I have to see. Hold on. I couldn't find presentation right now. Just check. If not, I will send you. So in continuous flow line, usually the product will continue on the line, and people like for an example, if you take automobile assembly line, so those are like continuous flow lines. In intermittent, as I remember, just check what is. Uh, it is those, I mean, first continuous type, it's for mass production. In intermittent, you can, it is for group or batch production. So the flow patterns can be changed, like in the direct flow direction, or the sequence is uh, changeable. So just find out industries, what type of industries those are used. So as I said, in flow lines are usually suitable for manufacturing facilities, like with mass production. So uh, there are certain drawbacks. Understand those. Also should be given in the presentation. And there is another term like dedicated transline. It's like the type of transline that we just talked about, continuous or intermittent. And also there is a flexible transline, same as intermittent. Um so in flexible, as it says, it's flexible for change in the flow pattern. Maybe you can say two machines are there, like lathe machine, milling machine, three machines, lathe machine, milling machine, and drilling machine. So in between that, maybe a robot arm is there. So robot arm can take uh, any product, I mean, from any, for any sequence, from machine 1 to machine 2, or machine 3, machine 3 to machine 1, or machine 2 to machine 1, like that you can program it in different ways. So those are flexible transfer lines. Just read about it. I might be wrong. You may be find out on presentation. So do this by yourself. Just find some examples. So you have to know what is a flexible manufacturing system and a fixed manufacturing system. So in flexible manufacturing system, uh, did I, as I remember, we did about flexible manufacturing systems. Did we? Hello. අපි කරන්නේ flexible manufacturing systems. නැද්ද? Can anybody answer? No, yes.
Not sure, sir.
Yes, as I remember, I did. Okay, if not, I will. Okay, this is flexible manufacturing systems are. Those are flexible for uh, operating in different sequences. For an example, as I said, three or four workstations are there: drilling, machine, milling, lathe, like that. So when we want to manufacture different kind of products, we can use flexible manufacturing systems easily, so that depending on the manufacturing product, we can change the manufacturing sequence. So for batch type or job shop type, flexible manufacturing batch type, job shop type, flexible manufacturing systems are ideal. For mass production, it's only one product will be going through the facility, the factory. So for that, flexible manufacturing will be expensive, but you can use. So fixed manufacturing systems are used in mass production facilities. I will send you some notes if I remember I did it, but not sure. So remember that. What is the difference? What is flexible manufacturing? And as I said, what are the advantages of flexible manufacturing? As I said, the advantages can yes.
ඒ කියන්නේ සර් මේ කියන්නේ දැන් මට මතකයි උදාහරණයකුත් සර් කිව්වා කියන්නේ අර වෑන් නුත් වෑනුයි කාරුයි දෙකම
Oh,
එකම ලයින් එක
oh,
යනවා නම්
oh, oh.
මේ ඒ කියන්නේ process එක කියන්නේ සම්පූර්ණයෙන්ම මැෂින් ඔක්කොම වෙනස් කරන්න ඕනේ ප්‍රෝග්‍රෑම් එකයි ඒ ටික ඔක්කොම ඒ ටික විතරක් වෙන චේන්ජ් කරන්න පුළුවන් කියලා.
Oh, ඒක තමයි flexible manufacturing. ඒ කියන්නේ මේ batch production එකේ එක batches යනවා නම් ඒතරට ටක් ගාලා මාරු කරන්න පුළුවන්. ඒ කියන්නේ physical setup එක මාරු කරන්න නැතුව මේ operation sequence මාරු කරන්න පුළුවන්. ඒකයි. දැන් fix manufacturing systems වල physical එක මාරු කරන්න බෑ. මාරු කරනවා නම් ඒ කියන්නේ ඔක්කොම machine ටික මාරු කරන්න එපායි. ඒතර ඒ කියන්නේ ඒක හදලා තියෙන්නේ එක product type එක විතරයි. ඒ production line එකේ එකම line එක එකම type එකේ බඩු හැදෙන්නේ. දැන් flexible manufacturing systems තියෙන තැන් වල එක જાති බඩු හදන්න පුළුවන්. මොකද අපිට physical location එක මාරු කරන්න නැතුව මුළු system එක මාරු කියන්නේ manufacturing system එක මාරු කරන්න පුළුවන්. ඒකයි flexible manufacturing කරන්නේ තියෙන්නේ. that's it. ඒතර advantage එක ඒකයි. Next question is describe the role. Oh, then question number 17. It's about CNC machines and robot. So CNC machines are used in flexible manufacturing systems as without difficulties you can reprogram the part we have to manufacture just just to CNC machines usually got several tools like 24-30 tools, so we can program. Actually it's you can say it's a machine manufacturing cell, CNC machine, because it can be done drilling operation, milling operation, lathe, or the turning operation. Some machines can do, and boring, kind of those many kind of operations can be done. So it's kind of a manufacturing cell, and it's flexible because we can change operating sequence. And robots are used in between machines, so it is easy to uh, program. Like we don't have to physically move the robot or the machine, so machine order, transferring order can be reprogrammed. So we are using robots in flexible automation or the manufacturing systems. And question number 18. In the presentation you have given some equations. Let me go to that. Okay, these are calculations. So up to this, from 10 to from 11 to 20, I'll tell you what are the important questions that you have to remember, do before CAT. So the 11th one is 11, question number 11, question number 12, question number 16, question number 20. So uh, go through those. I will change the slide. I think you can see now the single station manufacturing. Actually, we didn't do the calculation that day. I said we will do later on. Yes, we will do later more deeply. But for now, you just need to know something. So one in calculations, one thing you have to know. Calculating cycle time. Cycle time is piece per hour or time required to produce a part. So the total production time divided by number of parts will be the cycle time. And we have to remember these equations. Workload Actually, you don't have to remember, but just know this equation. Workload is equal to quantity of products to be produced in a period and cycle time. So multiplication of Q and TC, and so workload is then actually the workload is what we have to achieve in a period of time. Remember these definitions, and this also can be considered as a key performance indicator. So okay, then we have another equation to calculate number of workstations. So workload we can find from this equation, and we are using another definition, available time on one machine. So how long one machine can use for that work, that is what it means. So you will have this question, example number 1. It is similar to in your assignment in your assignment 20th question, last question. So for an example, this says certain facility produce 800 shafts during a week. Shafts are identical, so the same kind of shafts are produced. So the cycle time is given 11.5 minutes, and the question is determine number of lathes if 40 hours are available on each lathe. So we have available time 40 hours. Uh, uh, First what we do, we calculate the workload. So the workload is we have to produce 800 shafts in and the cycle time for a shaft. So to produce one shaft it takes 11.5 minutes. So it's in minutes. So what we do, we will calculate the workloads in minutes in 9,200. So you convert into hours, 153 hours you get. And this equation gives how many machines that you need to do the work. So determine the number of lathes. So to calculate the number of lathes, we have now workload here calculated 155.3 whatever, and we know uh, each machine has only 40 hours, so divided by 40, so you will get something approximate to closest value, I mean close value. So 3.82 the equation answer. So you cannot have 3.82 machines, so you take 4 machines. So this kind of question you practice, I mean the last question, 20th question. These are, we go through these later on again. It's the same, almost same kind of calculation we will do more specifically when we need to do more work. So for that's all for now. So shall we stop now? I don't take your time much. You may have exams. If you have questions, you can ask me. And I forgot to tell you one more thing. We didn't do. This is a this is kind of a general question that if you go through these sessions or read books, you will find. I want you to know what is an assembly line. And there are like production lines and assembly lines. So how do you identify what is the difference between production line and assembly line? You know it already. So that's all that you have to know before the cat, and good luck. So I'll stop from here. And one more thing, you don't I mean, like, I saw last time for CAT1 paper, what CAT1 answers, you some of you have written like pages for single answer. Remember that you had 10 questions to answer within 45 minutes. So manage your time and don't try to write a lot. Just be specific, write to the answer. And last time, like some of you wrote the same answer for all the questions. That is correct in a way. Correct means, because say what are the benefits of, say, single station manufacturing system, and I can ask another question can be what are the benefits of flexible manufacturing system, and there can be another answer, what will be the benefits of cellular manufacturing. So if you say productivity, efficiency, and whatever, those are actually benefits, but I expect you to write specifically the benefits of each type, not the generally. Okay, so read the question and answer short. Give us a short answer, and if I understand that you have understand the question and uh, you know what how to answer, and you have the you know the meaning, then you'll get full marks. Okay, I'll stop then here.
Okay, sir. Thank you, sir.
You're welcome. Any
Thank
Thank you,
questions?
you.
sir.